Okay, this is our group project on the bulkhead design for our biomimicry project. The problem we are trying to face is how different ships sink faster, especially larger ones such as cruise liners or cargo ships. So the way we plan to attack this is basing the ship's bulkhead designs on Nautilus shells, which the way they're designed allow water in certain groups, but due to the pressure buildup in different segments, it doesn't allow the water to get much farther than that. And this will help with causing ships to sink faster because the water won't spread out as quickly, causing the ship to go down. The inspiration of this idea was because all three of our group loves the ocean, and when we were thinking of ideas for the project, the Nautilus came to mind, and Robert thought of an idea that, since the way they're designed, it would be great to make a ship bulkhead based on this. What will be changed in this project will be the amount of ships sinking every year and the amount of people dying, as well as with less ships sinking every year, there won't be as many oil spills, as well as other constant influxes of certain pollutants, which can affect large swaths of ocean. The bulkhead helps because it's the barrier between the water and the ship, and this prevents the water spreading throughout the sinking ship, and they are helpful because they don't allow the ship to sink as fast in case of an emergency. The background research we have, there wasn't too much to it because most of it was just based on prior knowledge from Robert. But from the notes, it's based on the structure of the Nautilus. And as you can see here, we have a rough sketch from the Nautilus compared to a ship bulkhead. The organism we plan on basing this on is a Nautilus shell, which is an animal with a shell design similar to what we'd like to use for the bulkheads. Nautilus shell, when born, has about 4 chambers, and when fully an adult, it has 30 small chambers. These chambers are filled with gas and water. With these two things, the Nautilus can adjust its buoyancy, and we will use these chambers to fill with water and filter themselves out or pass the water, just like the bulkheads are described to do. This is the general design of the bulkhead and what it will do. The thing in the middle on the top image is a pump, which pumps the water out. So as it spreads out, it will be continuously pumped out. The biology of our design, the Nautilus shell is made up of segments just like a ship. Each segment is completely watertight and has a tube that regulates the gas pressure in the shell to make the animal more or less dense than the water so it can sink or float. We thought that we could use the same principles from the Nautilus on the ship, and so we could design the bulkheads after the animal to help the ship when a collision or puncture would happen. The only possible limitations or obstacles to overcome are major shipping companies to change their boat design, as it's very expensive and there's already so many boats out there with the original design. So that would be the main problem that we'd have getting past. The social and environmental benefits would be less oil spills, as when a ship sinks, the gas and oil spill into the ocean, and this can cover huge swaths of water, killing a lot of animal life and just ruining the ocean in certain areas. And it will save more lives because if there is, in case of a sinking, more people will be able to get off given the longer amount of time it takes for the ship to sink. Whoops. Who would use this? Large shipping companies such as barges or like trade vessels that carry large amounts of cargo at any given time, as well as cruise liners. Robert came up with the ideas, Tiffany did the slides, and I did the video.